All right. So now that we've spent, at least in class, we spent an entire day talking about what heat is, how heat moves from the warmer object to the cooler object, and things of that nature. Now we need to talk about the three main ways that heat transfers, and that's conduction, convection, and radiation. Now I know that some of this video probably runs over into the video from yesterday, but we're still going to cover the three things pretty thoroughly today. Now, conduction. Although this definition is correct, the passing of heat through a material while the material itself stays in place is correct. I think a better way to describe this is to say this is the passing of heat when two things are touching. If you put your hand on a hot stove, the heat from the stove transfers to your hand very quickly. I'm excited in fourth quarter to talk about how our brain realizes that through our nerves and neurons, and how those messages are sent so quickly that we pull our hand back before a lot of damage can be done to our hands. But that's a heat transfer through two things touching. When you fry an egg in a pan, the egg is touching the pan. You have two things touching. That is going to be another example of conduction. Conduction is the transfer of heat through touch. Now, one really cool thing that happens with conduction, especially in the summertime, is watching animals like elephants. They will dig out not a deep, but a patch of dirt, and because where they're digging, that's probably in the shade, it ends up being cooler than they are in the dirt. And what happens then is they will lay in that patch of dirt, and because they are hotter than the dirt, the heat from their body is transferred to the ground, and what that does is it actually cools them off. So they're using the process of conduction to cool off. When you go camping, if you go tenting at all, you definitely want to have some sort of a sleeping pad under you, especially in the cooler months. Otherwise, if you're just laying on the ground, you can get very cold while camping because you don't have that insulated stuff between you and the earth, and the whole night that you're sleeping, there's heat being pulled away from your body, and you can wake up pretty cold. Depending on where and when and what time of year it is, you could even get into like a hypothermic situation, which would not be a good thing. So anytime things are touching and heat's being transferred, it is conduction. You see this person grabbing this pot. They are touching it. The heat is transferred from the pot handle to their hand through conduction. Cooking an egg on a stove, ice melting in your hand, that was like the entire lesson in class yesterday. Burning your finger on a spoon that's in a cup of hot coffee. And is that a wild process that's going on there, because the spoon is in the hot water, and the hot water is convection. The spoon gets heated up, but then when you touch the spoon, it's going to be conduction. Pretty wild. And then we already talked about an animal laying on a cool patch of dirt are all examples of conduction. Convection. Convection is I like this definition better than the other one. I gotta be honest. The transfer of heat through the movement of a gas or a liquid. You may have a convection oven in your house, and it is a little different than some of the other ovens. In a convection oven, you have hot air that's circulated through the oven. We have those here at school. You can hear them when they open the doors with the air moving around inside of those. Pretty awesome. Convection happens in water. If you've ever watched a pot of macaroni boil, you'll notice how the macaroni comes to the top of the pot and then it ends up kind of sinking back down. Well, what's happening is the hot water that's being heated at the bottom of the pot rises, because we know hot rises, and the cooler stuff that's at the top of the pot starts to sink, and you have this convection cell, this circle of hot water rising, cold water sinking. And that's a pretty amazing thing to see, and we're going to do a really fun experiment with that in class. But you have that convection cell that we saw in the video in class yesterday of hot going up, cold coming down. That happens outside as well, not just with water. It happens with air. The sun will heat up the sand on the beach. The hot air will rise. Cooler air from over where the ocean would be will sink in to replace that. And that's one of the reasons why you have that breeze, that sea breeze during the day when you're at the beach, is because of convection. It's that movement of heat, either through a gas or through a liquid. And here you can see that convection cell where warm is going up and cold is going down. This is a convection cell, but that's what convection looks like. And what's happening is, as that hot is going up and the cold is going down, it's basically waiting until you get that equilibrium where the water is heated the same throughout, which is kind of tough to do because up here is always going to be cooler than down here, because this is where the heat source is, and it's going to stay hotter down here. And up here is closer to the other air, and it's going to lose the heat to the air, and then you're constantly going to have this convection cell. Boiling an egg in a pot of water, convection. The movement of thermal energy around the earth. Now, again, like I've said, a lot of this is the beginning and the basics of the weather unit we're going to start. Convection is a huge part of weather. That is how the winds are moved around the earth, like things like trade winds and the polar easterlies, the prevailing westerlies. Those types of things are all moved through convection, where hot air is rising and cold air is sinking. Anytime you're boiling water, you have convection. Radiation. It says the transfer of heat through electromagnetic rays. There's no touching involved in this. And so basically what you're thinking about is sun rays. Like if you're talking like the sun heating up the earth, that is going to be an example of radiation, because there is no touch. It's not hot air. It's electromagnetic rays. It's that radiation coming off the sun, that heat waves. You can see the heat waves coming off the sun are how the earth is heated up. And again, it's due to the radiation heating up the earth. And then you have, because of the radiation, you have convection going on. And because of convection, you have a lot of the winds and weather and things of that nature. It's pretty amazing how they all kind of work together. But you have radiation. There's no touching going on. And honestly and truthfully, there are typically two big ways. There's maybe some more I can think of, but there's two big ways that I see consistently as examples. The sun heating the earth and getting warm. Now this is important. Beside the campfire. Okay, you start putting your hands over top of the fire. We're in a whole different level, completely different thing. We're talking convection then, and we'll go over the reason why on that. But when you're sitting by the fire, beside the fire, which is typically what people do. People don't sit over top of the fire very often. When you're sitting beside the fire and you're getting warm, that is going to be radiation. If you have a light bulb on in your house, you can feel the heat coming off of that. That is an example of radiation. I know the video we watched talked about microwave radiation, when you put something in a microwave. That's a little different. But it's still electromagnetic rays heating something up. So I think that one's a little different, though, and it probably won't show up on a test or anything. You're usually going to have something about when it's radiation. It's going to be the sun heating the earth. And again, radiation, oh my goodness, it plays a massive factor in everything. Think about the water cycle. If it weren't for radiation, we wouldn't have evaporation. No evaporation, you have no condensation. No condensation, you have no precipitation. So the heat from the sun, the radiation heat, drives the water cycle. And I think that that's something that's very important. If you don't have radiation heating up the earth, you don't have the earth getting warm and then hot air rising and then cold air sinking, so you don't have convection. And so there's a lot of things that go on with the sun heating up the earth that's extremely important. So there's radiation, conduction, and convection. None of them are more important than the other. They are all like this one giant thing that we've labeled as heat transfer, and they are all very, very important. I know that seems like a little short on that, and obviously we will dig a little deeper in this as we go through the week, but today really is just focusing on conduction, convection, and radiation. Now for our class, people in class, just know that I'm actually going to take them outside, and I'm going to have everyone sit down, like on the ground. And we're going to sit there for a while. And what we're going to realize is, I think a lot of people are going to say, hey, Mr. Boiling's like, my rear end is getting cold. Well, we're going to talk about why. Well, the heat from your body is moving to the ground because there's a difference in temperature. So when you sit on the ground, we're going to see conduction going on right then. If I can, I don't know if I'm allowed to do this, but if I can, I'm going to get out the fan and kind of run a drop cord out my window and have some air blowing. I'm going to let some people sit in front of the fan versus people not sitting in front of the fan, and they're going to realize pretty quickly that if you start moving air around you, convection, you can lose heat very quickly due to the air. I sleep in a hammock when I go camping, and I have to make sure that the underside of me as well as the top side of me are both insulated, because I'm not going to lose any heat due to conduction. I'm not touching anything but the hammock. So I'm not losing heat to anything as far as touch goes, but I have the wind moving under me and I have the wind moving over me, and you're going to lose a lot more heat through convection when you're sleeping inside of a hammock while you're camping. And so it's something you have to take note of and think about. And then, obviously, I don't think this morning they're going to get much of experience of this, but in the afternoons, I'm going to have some people sitting in the shade. I'm going to have some people sitting in the sun, and I think they're going to notice very, very quickly that radiation plays a huge factor in how you can stay warm outside, or on a hot summer day, you don't want to stay so warm. You would actually want to be in the shade. And so we'll go outside and actually, I guess if you want to say it this way, like put our hands on conduction, convection, and radiation while we are out there. And that's really all we're going to do as far as outside goes. You could probably, if you have any tile surface in your house, you could probably just go sit down like in the kitchen on the tile or something, and you're going to notice a difference in temperature between the tile and the carpet and other things because of insulation. And you can sit there for a moment, and you'll start to realize that the heat is moving from your body to the tile in the house. And so if you wanted to kind of do what we're doing, you can think about those kind of things as well. But today is really just the introduction of conduction, convection, and radiation, and then we're going to continue to review for the benchmark that is coming up, I believe, next Thursday. All right, kids, that's it for today. Don't forget to smash the like button and subscribe, because everything after this, if you go into Nearpod, you can watch the video on study jams, and then there's a heat exchange, like quote-unquote quiz at the end, just to kind of check up on yourself. All right, we'll see you later, kids. Bye-bye.